Okay, so I've already pulled my data in here, and notice that your column A is just labels for the data. So let's say you were checking your typing speed for 30 trials in a row. Instead of date, you might put something like trial and then 1, 2. If you highlight those, you can drag down and give yourself 30 numbers there. But then the data would come in the next column. So I've got my date, and then the number of steps according to my Fitbit that I took that day. And I'm only counting the dates when I had my Fitbit on. So notice January 3rd and 4th are not part of that list, for example. Okay, so the first thing I want to do is just get a sense of, in fact, I'm going to make this a little larger. Just get a sense of what the average number of steps I took was on the days that I had my Fitbit. So I'm going to just type the word average, and then I'm going to actually do the formula to calculate the average. So I'll type the word average. Notice that one shortcut I can do is click on the column header, and that'll just take the average of every number value in the column. So in this case, it gives me 9,172. One advantage of using that, now I do have to make sure I don't have like it all totaled up at the very bottom, because that total, it would count as part of the average, or I have other numbers down there. But if that column is completely dedicated to these step counts, like I have it, a nice thing about this formula is if I would later add more dates worth of data, it'll automatically calculate the average for those also. So that's my average. But let's say that I really wanted to know in general, at this point in my life, how many steps am I getting per day? So this 9,100, it's a pretty good estimate, but I realized that this portion may be a little lower than normal or a little higher than normal. So I want to create what's called a confidence interval. And to do that, the first thing I want to do is create a margin of error. In other words, my best guess at my average number of steps on days I wear my Fitbit is 9,172. But then there's a little plus or minus something, and that's the something I want to find. That's the margin of error. So to do that, I'm going to type in an equal sign and then the word confidence. Notice I have a couple different choices. If I knew for sure that this was a normal distribution, I could just use the plain confidence formula. But we do not use that. In general, if you have a sample and you're trying to estimate something about a larger population, then you want to use the t. So you're going to put confidence.t parentheses. And if I click in that question mark, this gives me some support on, okay, what do I need inside my formula? Well, the first thing it's asking me for is alpha. So what's that? Well, when we have a confidence interval, it's associated with some percent level of confidence. So in this assignment, I'm asking you for a 95% confidence interval. 95% chance that we're going to get the population value somewhere inside of our interval. But that leaves a 5% chance that we're not. So that 5% is what's called our alpha level or error rate, type 1 error rate. So 5% would be written as 0.05. If you wanted a 90% confidence interval, the only thing you'd have to change is it would be 0.10, 10% chance of error. If you wanted an 80% confidence interval, that'd be a 20% error, 0.20 alpha. So alpha is just the opposite of your confidence level. Then we have our comma and our standard deviation. Now I could calculate that separately, but it's much easier just to do it as part of the formula. So I'm just going to type in stdev.s, because I have a sample here. I'm trying to represent something about a larger population. And by the way, the larger population is not lots of other people. the population here is all the days of my current life. And I just have a sample. I have some of those days worth of data, but I'm trying to estimate the larger population. So it doesn't always have to represent a population full of people. In this case, I'm not at all generalizing to other people. So I do the stdev.s, and then I'm also going to do column B again, same thing, and comma size. So I could just count the number of data points I actually have, or again, there's a formula, I can just use count and BB. If you're not using count, so count automatically subtracts the text, like that top column there. Let me show you. The top column is just the word steps. It's not going to count that as one of the data points. If I highlight this, notice it's giving me 109. So I have 110 rows in my spreadsheet, but since that first row is column headers, it's subtracting that out, which is what I want. I only want to count the cells that have the numbers in them. So this formula gets it to me right away. And then close that out. And that'll give me my plus or minus would be 749 or 750. So right now I know that my average number of steps is 9,172 plus or minus 750 steps. And let me go ahead and put this into a 95% confidence interval. This is going to involve two things. The confidence interval is represented by the lower point and the upper point, and then really it's everything in between that is what we're confident that the population value actually is. So to set that up, all I have to do is start with my average, and then I hit minus that margin of error. So this is my lower number. And then here I'm going to hit equals my average, same thing, plus my margin of error. So I'm just starting at my average and I'm subtracting the margin of error and adding the margin of error. And then I'm going to do one more thing, just because I have so many decimal points here, it's messy. I'm going to select these, go to Format, Number, and scroll down here. I'll just get the plain numbers. You don't have to do that if you don't have messy decimals on your numbers, but it makes it easier to read. Okay, so what does this interval actually mean? I'm going to insert a comment here. First of all, what it does not mean is that 95% of the days I take between 8,422 steps and 9,922 steps. It does not mean that. I mean, look over here at my actual data. In the data that we're looking at here, there's only one day that would actually be in between these numbers. So certainly it's not what that means. What it does mean is that the average number of steps I take per day on days I wear my Fitbit, because the other days could be quite different, is probably between 8,422 and 9,922. So I'm 95% confident that it's somewhere, that true average is somewhere in that range. And you might say to yourself, well, the true average is just 9,172. Again, that's on the days in between January and May 2020. But if I'm thinking about a larger portion of my life, and this is just a sample, or maybe I just got my Fitbit in January and I kind of want to know in general what my average is. This is a confidence interval for probably my true average number of steps per day is in between those. One thing I might know is, so some doctors might recommend that you take 10,000 steps a day. I think that's pretty arbitrary, but it could be pretty sure that I do not get that on average, because even in the best case scenario, I'm getting under that number. Not by a lot, but under that. So I'm going to go ahead and insert that comment. Now, the next comment I want to do, and the last step of the assignment, is limitations. So for me, the biggest limitation is that my sample is not random. So if I wanted to really get at how many steps I took a day on average, and maybe not even on average of the days I wear my Fitbit, but just in general on average, one thing I could do is, well, I could constantly wear my Fitbit every day, but I could also flip a coin, and if it's heads, I wear my Fitbit that day. If it's tails, I don't. Or maybe I even roll a dice, and if it's a number 6, I wear my Fitbit that day, and the other numbers I don't. And if I collected enough data, that would be a random sample of the days of my current stage in life. So the fact that this sample is not random is the biggest. A reason that might make a difference is maybe in the fall or in the summer, this is only going through May, I walk a very different number of steps than I do between January and May. Maybe more, maybe less. But if I really wanted a really nice confidence interval, I'd have a sample from days throughout the year, not just in this little stage of the year. Let me just put that in the comment. For example, the steps I take during January to May might be different from the number I take at other times in the year. Okay, and that's the assignment.